Hello everyone. In this part of the presentation, I'll walk you through question number 6, where we analyze how similar or different two students are based on their interaction with faculty. We'll use multiple distance metrics to compare their profiles and understand what each metric tells us about their behaviors. Understanding the challenge. Our goal is simple. We have two students who interact with faculty in different ways, and we want to measure how far apart their interaction profiles are. Different distance metrics reveal different perspectives, so this exercise helps us understand how data behaves in multidimensional space. Now our data, we are given two students. Student A, 22, 1, 42, 10 is the set of data for student A. For student B, the set of data is 20, 0, 36, and 8. Each value represents mentoring hours, project reviews attended, assignments submitted, and infrastructure usage. These four dimensions help us compare their academic engagement. Now, decoding the attributes. To quickly summarize, mentoring hours, how much one on one or group mentoring they received. Project reviews means how many review sessions they attended. Assignment submitted means a direct measure of workload and consistency. Infrastructure usage means how often they used labs or computing resources. This gives us a well rounded view of their interaction patterns. Now let's compute the differences. Before using any formula, we first compute the absolute differences for each attribute. As shown in the given table, notice that the biggest difference is 6. In the number of assignments submitted, this will strongly influence some distance metrics. As given in the table, uh, A minus B is the largest for 6, which is for assignments submitted, and the least for project reviews, which is 1. Now let's talk about the equilibrium distance. Euclidean distance represents the straight line distance between two points in multidimensional space. Now the steps here are: number one, square each difference, then add them up, take the square root. For our given example calculation, 4 plus 1 plus 36 plus 4 equals to 45. Square root of 45 is approximately equal to 6.708. This tells us the direct geometric distance between the two profiles. Now, the Manhattan distance. Manhattan distance works like navigating city blocks, only horizontal and vertical movement, no diagonals. We simply add the absolute differences: 2 plus 1 plus 6 plus 2 equals to 11. This metric is more sensitive to total overall difference than equilibrium because it doesn't square anything. Talking about Minkowski distance now. As given in the question, value of h should be taken as 3. Minkowski distance generalizes both Manhattan and equilibrium. Here we have used h equals to 3, which puts more weight on larger differences. Going towards calculation, cube of 2 plus cube of 1 plus cube of 6 plus cube of 2 gives us a summation of 233, and cube root of 233 is approximately equal to 6.13. So Minkowski gives us a value between Manhattan and equilibrium. Now, the supremum. The supremum distance, also called as Sheb- Chebyshev distance, looks only at a maximum difference from our table. The largest difference is 6 of assignments submitted. So the supremum distance is simply 6. This tells us what the worst case deviation is between the two students. Now comparing the matrix, each matrix tells a different story. Equilibrium gives tells us straight line difference. Manhattan tells us a total overall deviation. Minkowski gives us the emphasization of big differences, whereas Supremum focuses only on the largest gap. This variety helps data scientists choose the most appropriate method based on the situation. going towards the key takeaways now. To conclude, choosing the right metric matters. Each one highlights different aspects of the data. Minkowski distances amplify large differences, while supremum ignores all but the largest one. These metrics form the backbone of many machine learning techniques like clustering, recommendation system, anomaly detection. Understanding these distances helps us interpret multidimensional data more effectively. Thank you all for listening. This was question number 6. I hope this explanation helped you understand how different distance metrics provide different insights when comparing student faculty interaction profile. I hope you liked it. Thank you.